Alrighty then. Late in the afternoon, we're starting to feel a little bit tired. The coffee is wearing off, and we've got a lot more discussions to have, and we've got to get a little feisty about some of these things. So, over the course of yesterday, today, and probably tomorrow as well, you're going to hear a lot about AI, maybe. A little bit more about AI, a lot more about AI, some context, some models, some LLMs, this, that, and the other. But a lot of the times we forget about the fundamental infrastructure that we got to build. So, we use the internet, but we don't really think about what it takes to keep it running, to keep upgrading it, and how it's going to support all the new things that we need to do. When we first built it, we built it in the 90s, and we haven't really upgraded it in a long, long, long time. What we started doing when we built that thing was we thought we were going to have freedom of information. We're going to connect all the universities. We're going to connect all the companies. Everyone's going to get an IP address. You're going to have free-flowing information. Did not happen. Very quickly, we had all kinds of problems, like we ran out of IP addresses, then we created a new protocol, but then we didn't run out of IP addresses. We rolled out a cloud, we rolled out several clouds, and then we were like, okay, what's happening? Very quickly thereafter, with all the applications and all of our intellectual property on the internet, we started to really think about, okay, we use this for everything. Phones, our personal data, our privacy is now here, or the lack thereof. And then we gave all of that data to OpenAI and Anthropic and everybody else, and we didn't really think about what was going to happen after that. And now we're giving it to the agents. And the agents that we're going to build can do whatever they want on this infrastructure. They can program it in any way they like. They can do things with our data that we don't even know yet. And so at the end of the day, we're eventually going to have to come to some reckoning of what do we do with this internet that is now going to be occupied by less human beings and just machines doing all kinds of things. So what is the problem? Beyond so many problems, is that when we first built it, we built it on IP addresses. And we still run it on IP addresses. The internet protocols themselves, we never put any context into them. We never put any business logic into them. We didn't really put any governance into them. We basically said, if you know the address, you can fire anything you want at it. Then we get things like DDoS, we get man-in-the-middle, we get all kinds of things that can break into our systems. And so when we really think about the internet as it exists today, we put no concepts of sovereignty, of regulation, of compliance, basically anything into the internet framework. It's an IP address, it's a URL, and you can fire anything you want at it. And now we're in a world where, with all of our information inside the LLMs, the public clouds, and a world that is getting kind of insane every day, between the governments that we have, between the applications we create, we have to start asking, what are we going to do about this? How are we going to think about the fundamental infrastructure if we're going to let loose a whole bunch of agents into this world? This is where we have to start asking, as people who are building this and have to think about this on every layer, what does this infrastructure need? Are we asking these questions of all the people that we're talking to, all the vendors, all the application developers, the government, the telecom providers, the cloud providers? What are you doing about these things? So when I think about this future landscape, the first thing that we want to ask is the movement of data deterministic? When an agent builds an application or data pipeline, do we know where the data is going to go from point A to point B and everything in between? Is it deterministic? The internet is not currently deterministic. It is a best effort, fire, and we're going to try and find a way to it. It's not deterministic. When you think about data and protecting your data, you now demand of the internet, you've got to be deterministic. The second big thing becomes sovereignty. Now, we have the luxury of being in the United States where, because we have so much tech and so much innovation, we don't really worry because everything ends up in the US one way or another, but everybody else is thinking about it, and we really should think about it too. We love to talk about our borders on the news and everywhere else. Do we talk about our borders in the data ecosystem? Is the data leaving the country? Is the data entering the country? Is it coming from places it shouldn't? Are we sending it to countries we shouldn't? These are all the questions that right now we don't really ask. When you think about building data centers and where your GPU clusters will run and where your inference will run, do you think about jurisdiction? Do you think about lawful intercept? Do you think about the rights that will get imposed on where this data is and where this data moves? And then finally, at an overall holistic level, I mean, people will have these esoteric conversations about UBI and how we're going to fund that. If data is a commodity, do you think about taxation? Do you think about monetization of individual bits of data and what they represent? So fundamentally, your data taxonomy needs to start evolving with sovereignty in mind. Where is it? Where is it moving? Who has it? And what are the laws around it? That's very rapidly going to go into policy awareness. And this is not just technical policy. This is policy for the people that do risk and insurance and financial services around what's the long exposure? What happens if this data gets leaked? How do we insure these things? Because, you know, now, if someone does a very targeted attack on, say, Anthropic or OpenAI, how much data can they get out of it? How many governments and citizens have their personal data? How many people are using ChatGPT as their therapist? That has no legal protections. None. All of that is subject to subpoena. All of that can be exported. All of that can be stolen. And so when you think about policy awareness, the internet has to have rules around what policies are enforced around all of these things. And then finally, you have to think about the real-time programmability. Not just MCP servers as wrappers around APIs around existing infrastructure. At a certain point, you want to make the argument that the agent should be able to program the data plane itself. You should be able to set the context in the packet headers that says this data is US data, is payments data, is not allowed to leave these boundaries, is only supposed to stay on these pathways in these jurisdictions. That's already starting to happen. And very quickly, I know we have KYC rules on who can open a bank account, but an agent can get a stable coin. And it's going to be able to do lots of things that we have not accounted for. So our agents now suddenly funneling resources into other geographies. When you really think about the nature of what everything that is being built here represents, is that data is a very, very powerful commodity that is subject to more than just intelligence. It is subject to risk, insurance, and sovereignty implications. And that we really need to imagine the internet in a whole new way in terms of how we build it. So, that's a whole lot of possibly fear-mongering. There is concern. Some of us might go, nah, that we don't really have to worry about it. We'll figure it out as we go. And some of us will go, this could be bad. This could be really bad. What do we do? At Graphiant, we started to think about how we would build this kind of infrastructure out. We had to account for the fact that AI and agentic systems will be literally everywhere. They'll be in the cloud, they'll be in the data centers, and then we'll still have companies like Bank of America who will be running systems that are older than I have been alive or my parents have been alive. And they will never upgrade. And they will remain the same. There are mainframes that are still running COBOL. I don't know anyone here that writes in COBOL. Maybe there's someone. Maybe there's someone. But when we really think about this, right, we're talking about all this futuristic infrastructure, and there is still literally everything that has ever existed still here. We still have frame relay and ATM networks. We still have really old .NET systems that I don't know what we do with those. And then we talk about, periodically when auditors will come in and they'll say, what about the encryption standard? There are applications that have no encryption that have been running in the plane for years. And so this is where we start to have to ask, how are we going to roll out post-quantum cryptography? How are we going to roll out sovereignty? How are we going to secure everything that has existed before that now has open access to an agent? So at Graphiant, what we started to do was reimagine the internet protocols and start deploying them with carriers and data center and cloud providers across the world. We started going into the Equinix facilities. We started deploying it on AT&T infrastructure, on Verizon, on Colt, on Vodafone, on NTT, on Saudi Telecom, on Etisalat, basically every carrier we could find across the world, across the data center providers, across the cloud providers. The notion being, if the protocol has context and the ability to set jurisdiction and logic, then the agent can directly program the network in the way it wants, and we can enforce rules on what happens to the data. From there, we started to extend out into all the different cloud providers. And as we started to roll these kinds of services out, it has been an interesting experience to see which customers adopted first. We thought, wrongly, that the enterprise would be the first ones to adopt, that they would be forward-looking, that they would be innovative, that they would understand the implications and adopt. That has not been the case. The enterprise is actually experiencing what I would say is straight-up paralysis. They are terrified of the SaaS apocalypse. They are terrified of what the agentic ecosystem will do to them. They don't have a clue on what to do. Then I looked at the telecom sector, and I was like, they are famously slow at everything. And they somehow are moving faster than the enterprise. And I think it isn't because they're wiser to anything. I think they're just looking at it going, we missed the boat on cloud. We missed the boat on pretty much every innovation that's happened in the last 25 years. We may as well get wise to the AI world right now, or we're going to miss out this as well. The most interesting adoption that I didn't really want to have to work on those projects right out of the gates has been government. National security is the top of everyone's mind because, well, I know there's a war going on, or several in the world, but the nature of the battlefield is the internet. How we think about data, how we attack data, what we do with it, what we do with drones and warfare and everything else, the internet is the new battlefield. It has been for some time, but now it has very, very immediate effects. I mean, you post GPS coordinates on OSINT and suddenly you're going to find that there's a missile strike on it the next day. That's how fast information and national security is being used. So we have to really think about this stuff. This is where, for us as Graphiant, we ended up getting pulled into building sovereign infrastructure in a lot of foreign countries, where they're just like, we need to build out sovereign infrastructure where our nation-state data doesn't leave our boundaries. And a lot of people suddenly went, China probably had a good idea with the Great Firewall, and now everyone's thinking we probably need a Great Firewall. And so that is leading into how we think about the fundamental infrastructure for AI. Once you have infrastructure of this nature, what we really start seeing is agent-to-agent commerce. What we're starting to see is we'll have first the human meeting. I'm going to meet a person, and they're going to be like, I have a project. Do you have an MCP server? Step 2 ends up being, do we know what we're going to do with the MCP server? And then we figure some of that out. Then one side will build an agent, and the other side will say, well, actually, I have my own agent. And then we're going to make the agents talk to each other. And then very quickly, it starts turning into, how do I build agent-to-agent connectivity on a network infrastructure that has jurisdictional controls, that has consent, that has risk and insurance policies baked in. How do I make sure that the flow of data that even agents are building is controlled? This is where we start to see the first adopters of this kind of capability. We're seeing more in the payment space. We're seeing B2B payments take off as people experiment with agents and stablecoins and looking at new kinds of payment interactions. We thought this would be more like people would be exchanging model data, but it really has turned into a conversation about money. People really are looking at new ways of how to create new payment networks. This is where I think when we think about the implications of every application here and what sort of led Graphiant, myself, my team to be here, I'm not really looking here to pitch to and find a bunch of customers. I came here to find partners, people who look at the internet, people who are building data centers, people who are building agents who recognize this reality that we need to think about our infrastructure with sovereignty, with insurance, with risk in mind as we build payment structures, as we start rolling out agents that will have more and more autonomy, and sooner or later, a credit card that they can just buy and spend and do whatever we allow them to do. When I think about the future, and this is where, after this, what I'm really looking forward to is finding people who look at data centers and go, is this safe? Is this built the right way? When people look at payment systems, is this safe? Is it built the right way? We're rolling out agents to do marketing and email and literally access every element of our lives. We already gave up so much of our data to social media and everything else. Now we're giving literally everything to the agents. And now we're going to ask, is it built safe? Is it okay? What happens if someone weaponizes this? Because that is what the nature of the battlefield is. This is not meant to terrify. This is not meant to be ominous. I think if we are pragmatic, if we are thoughtful, if we focus on these kinds of challenges, we can build the internet with that in mind. We can upgrade the internet in mind, and it won't still be the same thing that it was when we built it in the 90s for phone conversations. We're in a new era, and we should reimagine every layer of our infrastructure. I'm going to wrap up with just a callback to the keynotes yesterday. There was like the 5-layer AI cake. This is the glue. This is the connectivity layer in the layers that you need. I wouldn't say it's the frosting. It's the layers that separate the other layers. When you cut through the cake, when you're going through an ice cream cake and you're getting vanilla and chocolate and strawberry, you need a little bit of a flair to give you that flavor profile, that distinction. Cleanse your palate, give you a sense of I've gone from one flavor to the next. The network connectivity layer is that, and we should really, really be focused on building that for the new world. And that's what we're doing at Graphiant. Thank you for your time. I hope you enjoyed this one. This is a different style. I hope you walk away with thinking about some of the things that we've talked about. I appreciate it. Thank you so much.